Episode 3, Detecting and Defending Against Plant Poisons. Welcome to the final part of the science behind poisonous plants. In this episode, we'll look at how humans, and even plants themselves, deal with toxins. How do we detect them, defend against them, and sometimes even neutralize their effects? For much of history, poisoning was nearly impossible to prove. The victim might collapse with nausea, convulsions, or paralysis, but the cause was invisible. Without modern science, poisons were the perfect silent weapon. That began to change in the 19th century thanks to advances in forensic toxicology. One of the most important pioneers was Mathieu Orfila, a Spanish-born chemist who worked in France. In 1815, he published Traité des Poisons, a landmark text that established toxicology as a science. Orfila introduced chemical methods to detect poisons in the body. He could prove in a courtroom whether arsenic or plant alkaloids were responsible for a suspicious death. Suddenly, poisoners faced real risk of exposure. Forensic toxicology was born. Since Orfila's time, our methods have advanced dramatically. Today, techniques like gas chromatography and mass spectrometry can detect toxins at parts per billion. A single trace of ricin, digoxin, or atropine can be identified in blood, tissue, or even hair samples long after exposure. These tools are not only vital in criminal cases, but also in medicine, where identifying a poison quickly can save a life. But what about antidotes? Some plant poisons can be countered with specific treatments. Digoxin poisoning, for instance, can be treated with antibody fragments that bind and neutralize the toxin. Atropine itself is used as an antidote for nerve agent poisoning. Activated charcoal, though not specific, is widely used in hospitals to absorb toxins in the gut before they can be absorbed into the bloodstream. Other poisons, like ricin, still have no reliable antidote. In those cases, doctors can only provide supportive care, keeping the patient alive while the body slowly processes or eliminates the toxin. This highlights how much we still have to learn. Interestingly, humans are not the only ones to develop defenses. Many plants that produce toxins also contain enzymes or compounds that reduce their effects. Cassava, a staple crop in many parts of the world, contains cyanogenic glycosides that release cyanide when broken down. But with proper preparation, soaking, fermenting, or cooking, these toxins can be neutralized. Indigenous knowledge of preparation methods has been vital in making such plants safe to eat. Animals, too, have adapted to plant toxins. Certain caterpillars can feed on milkweed despite its cardiac glycosides, storing the toxins in their own bodies to make themselves poisonous to predators. This chemical arms race between plants and herbivores has driven much of evolutionary biology. In modern times, our best defense is knowledge. Ethnobotany, the study of how cultures use plants, has preserved traditional wisdom about preparation, dosage, and safe use. Toxicology as a science now builds on this, providing evidence-based understanding of how toxins act, how to detect them, and how to treat their effects. Today, toxicology doesn't just protect us from deliberate poisoning, it safeguards food safety, regulates medicines, and monitors environmental pollutants. From detecting contaminants in drinking water to testing the safety of new drugs, the principles of toxicology shape our daily lives in countless unseen ways. The story of detecting and defending against plant poisons shows how far we've come. From the uncertainty of ancient times to the precision of modern laboratories, humanity has learned to live alongside poisonous plants. They continue to challenge us, teach us, and push us to innovate. And so as we conclude this mini-series, we're left with an important thought. Poisonous plants are not just hazards. They are part of the complex web of life, shaping medicine, science, and culture. By studying them, we learn not only how to protect ourselves, but also how to harness their power for good. Thank you for joining me on this journey through the science behind poisonous plants. Don't forget to like, share, and subscribe to Pete's World of Poisonous Plants for more explorations into the fascinating chemistry of nature.